Between June 6th and July 24th, 1944, the United States Army lost over 40,000 men in Normandy. That's more than the entire population of Annapolis, Maryland, gone in 7 weeks. A third of those casualties, roughly 13,000 men, happened in a 30-mile stretch of farmland, the French call the Bocage. Not from machine gun fire, not from artillery, from geography. Earthen walls, 5 to 10 feet high, centuries old. Root systems compacted like concrete. Every 100 yards, another wall. And every time a Sherman tank tried to cross one, it had to climb. When it climbed, it exposed the weakest part of its armour, the belly, to German guns waiting on the other side. It wasn't combat, it was execution. The official solution from Allied High Command took 6 weeks to develop. Committees, engineering studies, prototypes shipped back to England for testing. 6 weeks while men burned. A sergeant with a welding torch and stolen German steel solved it in 3 days. His name was Curtis Culin, 102nd Cavalry Reconnaissance Squadron. And when staff officers saw what he'd welded onto his tank, they laughed, called it scrap metal, junkyard engineering. 48 hours later, every welder in Normandy was working around the clock to copy his design. 500 tanks. Emergency orders from General Bradley himself. Because Curtis Culin decided he wasn't going to wait for a committee to save his life. This is what happened when practical genius met bureaucratic failure in the Hedgerows of France. To understand why they were welding garbage onto tanks in the middle of a war, you need to understand what was killing them in the hedgerows. The bocage wasn't hedges, not in any sense an English speaker would recognise. These were earthen berms, walls of compacted soil and stone, built up over 300 years by Norman farmers stacking rocks they'd pulled from their fields. On top of each berm, trees and brambles had grown so thick you couldn't see 3 feet into them. The roots went down 6, sometimes 8 feet, woven together like rebar. From ground level, they looked like fortress walls, because that's what they were, 5 to 10 feet high, sometimes 12. Every 100 yards, another one. Normandy isn't flat farmland. It's a maze of outdoor rooms, each one 50 to 100 yards across, walled in by these ancient barriers, thousands of them, tens of thousands. The infantry called it by fighting in a phone booth. You couldn't santish. Beneath the next field until you were in it. The Germans turned every field into a kill box, but it was the tankers who had the real problem. The M4 Sherman was built to fight on open ground, plains, deserts. It had 3 inches of frontal armour, sloped at 56 degrees. That was enough to deflect most German guns at range. The sides had 2 inches, angled at 45 degrees. Not great, but survivable if you kept moving. The belly had 2 inches. Flat. That's the trade-off in tank design. You can't armour everything. The engineers assumed the belly would never be the primary target because the belly faces the ground. So they saved weight, put it into the front and turret, and accepted the vulnerability underneath. In North Africa, that math worked. In the Bocage, it was suicide. Here's why. A Sherman weighs 33 tons. It's got 400 horsepower from a Continental radial engine, the same engine that powered some training aircraft. It can move at 25 miles per hour on flat ground. It can ford streams, climb moderate slopes, cross trenches. It was designed for mobility, but it wasn't designed to climb a 10-foot wall of earthen roots. When a Sherman approached a hedgerow, the driver had 2 options. Option 1, find a gate. But the Germans had every gate pre-sighted with machine guns, anti-tank guns, or mortars. Drive through a gate, you're driving into an ambush. Option 2, go over. To climb the berm, the driver revs the engine, builds momentum, and hits the base of the wall at speed. The nose lifts, The tracks claw into the dirt. The tank pitches upward at a 30, 40, sometimes 45-degree angle. At that angle, the belly is no longer facing the ground. It's facing forward, toward the next field, where the Germans are waiting. From the German perspective, it's a target range. They'd set up a Pak 40 anti-tank gun. 70 was 75 millimeters, same caliber as the Sherman's main gun, but with twice the muzzle velocity, aimed at the spot where they knew the Sherman would crest the ridge. They didn't have to guess. Every tank came over in the same spot. The crew couldn't see over the wall, couldn't suppress the gun before climbing, couldn't do anything but hope. The Pak 40 gunner would wait. He'd hear the engine. He'd see the nose of the tank appear over the berm. Tracks spinning, belly exposed. He'd put his crosshairs on the flat armour plate between the tracks. 2 inches of steel, no slope, point blank range. One shot, the 75mm armour-piercing round would punch through the belly, into the crew compartment, into the ammunition storage. If the crew was lucky, they died in the initial penetration. Metal fragments and spalling turning the inside of the tank into a shrapnel storm. If they were unlucky, the ammunition cooked off and they burned. Tanks don't explode like they do in movies, they burn. And it takes a long time. The other tanks in the column would hear it over the radio. They'd hear the commander screaming, or they'd hear nothing at all, just the sudden squelch of a dead channel. Then they'd see the smoke rising over the hedgerow, and they'd know they were next. June 15th, 1944, 9 days after today. Near the town of Saint-Lô. A company of Shermans from the 2nd Armoured Division tried to push through a series of hedgerow-lined fields toward the German defensive line. 7 tanks climbed the berms. 7 tanks were hit before their main guns could traverse to target. 90 minutes, 7 crews, 35 men. The rest of the company pulled back. This wasn't an isolated incident. This was the pattern. Every road, every advance, every attempt to break out of the beachhead stalled at the hedgerows. The infantry could get through, but without armour support, they'd get chewed apart by German machine guns and mortars. The tanks could break through with explosives, but that took time and gave away your position. And even when you blasted through one hedgerow, there were 10 more behind it. By late June, the front had barely moved 5 miles inland. Eisenhower's staff started running casualty projections. At the current rate, the breakout from Normandy would take until October, maybe November. The Germans would have time to bring up reserves, fortify the interior, maybe even launch a counter-offensive. The invasion, the largest amphibious operation in history, was stalling because of dirt walls and roots. Tank crews knew the math. They'd sit at the base of a hedgerow, engine idling, and they'd know. The other side of that wall was a coin flip. Climb fast, maybe the German gunner misses. Climb slow, you're a stationary target. Don't climb at all, your infantry dies without you. There was no good option. So they climbed, and they burned. The tankers were begging for a solution. High Command had one. It was idiotic. The Allied invasion of Normandy was planned for 3 years. 3 years of intelligence gathering, logistics coordination, and strategic analysis. Thousands of reconnaissance flights, tens of thousands of aerial photographs, scale models of the beaches built in England, so troops could practice the landing. They knew the gradient of the sand. They knew the location of every German pillbox. They knew the tide schedules down to the minute. But nobody knew about the hedgerows. That's not quite accurate. They knew hedgerows existed. The word Bocage appeared in intelligence reports. The aerial photos clearly showed the region divided into small fields with dark lines between them. French resistance fighters mentioned them. The maps showed them. What Allied planners didn't know, or didn't bother to investigate, was what those hedgerows actually were. From 10,000 feet, the Bocage looks like a patchwork quilt. Neat rectangular fields separated by thin dark lines. It looks managed. organised, like English countryside. Maybe the hedges are a little thicker than usual, but hedges can be driven through, hedges can be pushed over, they're vegetation. Nobody walked the terrain before D-Day. Nobody sent ground reconnaissance. Nobody asked the French resistance for specifics about height, density, or route structure. The photos were taken from reconnaissance aircraft flying at altitude to avoid anti-aircraft fire. High resolution for 1944, but still just a top-down view. So the planners made assumptions, reasonable assumptions, based on what they could see. They assumed the hedgerows were like the hedgerows in England, maybe 6 feet tall, dense brush, but ultimately just plants. Something infantry could push through, something tanks could drive over if necessary. They built their entire breakout strategy on that assumption. The plan was simple. Land on the beaches, secure the beachhead, then fan out rapidly into the interior before the Germans could organise a coherent defence. Speed was everything. The longer the Allies stayed pinned near the coast, the more time the Germans had to bring up reinforcements. Motorised infantry, armoured columns, rapid advances across open farmland. Except the farmland wasn't open, it was a labyrinth. When the first tanks rolled off the beaches and into the interior on June the 7th, the crews radioed back the same message. We can't get through. The hedgerows weren't 6 feet tall. They were 10, 12 feet. They weren't bushes. They were earthen walls with root systems that stopped a 33-ton tank dead. Eisenhower didn't see the Bocage in person until June 12th, 6 days after the invasion. He was touring the front with Bradley and Montgomery, observing the advance. Except there was no advance. The line had barely moved. When Eisenhower walked into a hedgerow-lined field for the first time and looked up at the walls surrounding him, he turned to his staff and asked, "Why wasn't I told?" Nobody had an answer. By then, hundreds of men had already died learning what the terrain actually was. The entire invasion timetable was collapsing. What was supposed to be a rapid breakout into France was turning into a static, grinding siege. The same kind of warfare that had killed millions in World War I. And High Command's response was to form a committee. The Army Engineering Corps began studying the problem. They consulted with tank designers back in England. They discussed modifications, maybe reinforced belly armour, maybe a different approach angle, maybe specialised vehicles. Prototypes would need to be built. Testing would need to be conducted. Results would need to be analysed. Estimated timeline, 6 to 8 weeks. Meanwhile, the official field solution was explosives. Engineers would move up to a hedgerow under covering fire, place satchel charges at the base, blow a gap in the wall, then the tanks would drive through. In theory, it worked. In practice, it was suicide. First problem, moving engineers up to the hedgerow while under fire. The Germans weren't blind. They knew where the Americans were trying to breach. Machine gun and mortar fire killed engineers before they could place the charges. Second problem, the explosion. A satchel charge makes noise, a lot of noise. It announces to every German soldier within half a mile exactly where you're about to attack. By the time the smoke clears and the tanks move through, the Germans have repositioned their guns. You'd trade the climb and die problem for the blast and die problem. Third problem, time. Placing charges, clearing personnel, detonating, waiting for debris to settle. 10 to 15 minutes per breach. And there were hedgerows every 100 yards, the advance slowed to a crawl. But it was the approved method. Doctrine, written down in manuals. But the tankerers hated it. They were watching their friends die while High Command studied the problem. They started improvising, trying to ram through at full speed, trying to find weak points in the walls, trying to use the tank's main gun to blast through. Nothing worked consistently. The roots were too dense, the berms were too tall, and if you tried to modify your tank, weld something onto it, add improvised armour, change the structure in any way, you needed approval from the Engineering Corps, archival, because modifications could affect the tank's centre of gravity. They could stress the hull. They could void the warranty if tanks had warranties. More importantly, unauthorised modifications meant you were taking responsibility if something went wrong. If your modification caused the tank to throw a track, or if it made the turret traverse slower, or if it compromised armour integrity, that was on you. So nobody modified their tanks. Officially, tank crews were resourceful. They'd add sandbags for extra armour. They'd weld spare track links to the hull. They'd mount extra machine guns, small changes, things you could justify as field expedients. But structural changes to the bow, changes that affected how the tank moved, that required Engineering Corps approval, which required testing, which required prototypes, which required... You see the problem. By late June, the front had barely moved. The casualties were mounting. The invasion was stalling. And somewhere in a headquarters tent, officers were looking at timelines and prototypes and test schedules. A sergeant from the 102nd Cavalry Reconnaissance Squadron decided he wasn't going to wait for the paperwork. His name was Curtis Culin, and he'd been thinking about teeth. Curtis Culin wasn't an engineer. He was a reconnaissance sergeant from Cranford, New Jersey. Before the war, he'd worked in a machine shop. He understood mechanical principles the way a tradesman does, through repetition and consequence. You learn what works because you've seen what breaks. The idea didn't start with him. It started with a soldier from Tennessee, whose name shows up in some reports as Roberts. Nobody recorded his first name. He's a footnote in the official histories, but he said the thing that mattered. Mid-June 1944. The unit was sitting in a field near Carentan, watching another column of tanks try to push through the hedgerows. They could hear the fighting, the roar of engines, the crack of German guns, the radio chatter going silent, one tank at a time. Roberts was watching a Sherman climb a berm in the distance, watching it pitch upward, belly exposed, tracks clawing for purchase. He turned to the men around him and said, "We need teeth on these things, like a bore, something to dig in so they don't have to climb." It wasn't a formal proposal, it was just a comment. The kind of thing soldiers say when they're frustrated and watching people die. But Culin heard it, and he started thinking about physics. The problem wasn't that the Sherman was too weak. It had 400 horsepower and 33 tons of mass. The problem was the approach angle. When you try to climb over an obstacle, you transfer your force upward. The steeper the climb, the more force goes vertical instead of horizontal. At a 45-degree angle, half your engine power is fighting gravity instead of pushing forward. But if you could bite into the obstacle, if you could dig into it instead of climbing over it, you'd keep the force horizontal. The tank would stay level, the gun would stay on target, and most importantly, the belly would stay low. Cullen started looking at what was available. Normandy in June 1944 was littered with wreckage, destroyed vehicles, blown apart fortifications, shell casings, and on the beaches, tons of German defensive obstacles that were now just junk cluttering the sand. Belgian gates, curved steel rails designed to funnel landing craft into kill zones, ramp obstacles welded from railway iron, and Czech hedgehogs. The Czech hedgehog was simple and vicious. 3 steel I-beams, each about 6 feet long, welded together in an X pattern. The idea was to rip the bottom out of landing craft as they approached the shore. If a Higgins boat hit one at speed, the steel would punch through the hull, and the boat would sink. They were everywhere. The engineers had bulldozed them off the beaches into piles. Nobody knew what to do with them. They were too heavy to move efficiently and too useful to scrap. High-grade structural steel, probably looted from Czechoslovakia's industrial sector before the war. Culin walked Utah Beach in mid-June, stepping over these piles, and saw something the engineers didn't. He saw the right material already cut to the right size. Each beam of a Czech hedgehog was made from I-beam steel, steel with a cross-section shaped like the letter I. It's the same material used in building construction because it's incredibly strong for its weight. The flanges on the top and bottom resist bending. The web in the middle resists shear stress. For its weight, it's one of the most efficient structural shapes ever designed. And the Germans had already done the hard part. They'd cut it, shaped it, and left it on the beach. Culin grabbed a few soldiers from his unit and hauled several hedgehogs back to their bivouac area. He requisitioned an acetylene torch from the motor pool. No authorization, no paperwork. Just signed it out like he was doing routine maintenance. Then he started cutting. The acetylene torch burns at 3,480 degrees Celsius, hot enough to cut through steel like butter if you know what you're doing. Culin had worked with torches before, cutting, welding, fabricating parts in the Aeon machine shop back in New Jersey. He knew how to adjust the oxygen-fuel ratio for a clean cut, how to move the torch at a steady pace to avoid warping the metal. He cut 4 prongs from the hedgehog beams, each one about 18 inches long. The exact length wasn't scientific. It was intuitive, long enough to dig into the root system, short enough not to throw off the tank's weight distribution. The next problem was attachment. You can't just bolt something sitting onto a Sherman's bow. The armour plate is rolled homogeneous steel, hardened against penetration, which also makes it hard to drill or tap. And bolts would create weak points, stress concentrations, places where the armour could crack under repeated impact. Welding was the only option. Culin positioned the 4 prongs on the bow of his Sherman in a pattern that made intuitive sense. 2 on the bottom angled slightly downward to bite into the earth. 2 higher up angled slightly upward to catch the root system. Spread them wide enough to distribute the load. Angle them forward so they dig in rather than deflect. Then he welded. Arc welding on armour plate is tricky. The steel is thick and heat resistant. You need to preheat the area to avoid thermal shock. You need to run multiple passes to build up the weld bead, and you need to make sure the weld penetrates deep enough to hold under stress. Not just surface fusion, but true metallurgical bonding. Culin worked through the night. The arc from the welding rod lit up the field in bursts of blue-white light. And sparks cascaded down the hull. The smell of hot metal and ozone filled the air. Other tankers came over to watch. Some of them helped on holding prongs in position, managing the welding lead, keeping curious officers away. By morning, Curtis Culin's Sherman had 4 steel tusks jutting from its bow like some kind of industrial predator. It looked ridiculous. It looked like exactly what the staff officer would later call it: junkyard engineering. Scrap metal welded onto a precision military vehicle. It violated every aesthetic principle of military equipment. Tanks are supposed to look clean, symmetrical, purpose-built. This looked like it had been assembled by a mechanic with a hangover and a grudge. But Culin didn't care what it looked like. He cared whether it worked. June 18th, 1944, early morning. Culin's tank rolled up to a hedgerow that had stopped in advance the day before. A 300-year-old berm, 10 feet high, roots like cables, thick enough that you couldn't see through the vegetation. The crew buttoned up. Culin gave the order. The driver throttled up the Continental engine to full power, 400 horsepower, all 9 cylinders screaming. The tank lurched forward, 30 miles per hour, 20 yards from the wall, 10 yards. Impact. The prongs hit the base of the berm and bit. Not a scraping deflection. Not a climb. A bite. The steel dug into the compacted earth and root system. The tank's momentum drove the prongs deeper. 6 inches, then a foot, then 2 feet into the wall. The engine didn't let up. The tracks kept driving. The prongs acted like wedges, splitting the pre-root system apart from the inside. 300 years of compacted growth, and it was tearing like rotten fabric. The Sherman didn't climb. It ploughed, pushing through the earthen wall like a ship through a wave. Dirt and roots and chunks of vegetation exploded outward. The make gun stayed level, the hull stayed level, the belly stayed low. 60 seconds after impact, the tank burst through the other side. gun already traversing. Commander already scanning for targets. Crew ready to fire. Total time, 2 minutes. A standard climb, if you survived it, took 5 minutes and left you exposed for half of that. Culin's tank emerged from the hedgerow with chunks of earth and vegetation still clinging to the prongs and the bow. It looked like it had been camouflaged, which technically it had. The debris from the breach acted as natural concealment. Accidental genius. The crew sat there for a moment, engine idling, looking at the field ahead. No German guns, no ambush, because the Germans hadn't heard them coming. The sound of the tank ploughing through was quieter than the sound of a tank climbing over. No tracks spinning in open air. No engine straining against gravity. Just forward momentum and tearing roots. Culin keyed the radio and said, "It works." Word spread through the unit in hours. By evening, tankers were walking the beaches looking for Czech hedgehogs. By the next day, other crews were welding their own versions, some with longer prongs, some with shorter, some angled differently. Nobody waited for approval. Nobody asked permission. They just built. Within a week, a major from the 2nd Armoured Division heard about it and asked for a demonstration. Then a colonel, then someone on Bradley's staff. June 24, 1944. General Omar Bradley, commander of the US First Army, the man responsible for the entire American sector in Normandy, stood in a field near Colombières, watching Curtis Culin's Sherman punch through a hedgerow like it wasn't there. Bradley watched the tank emerge on the other side, gun tracking, hull level. He turned to his aide and asked, "How many tanks do we have in theatre?" The aide checked his notes. "Approximately 2,000 in the immediate sector, sir." Bradley didn't hesitate. "I want 500 of them modified. You have 48 hours. The aide blinked. "Sir, we'd need authorization from Engineering Corps. We'd need..." "Bombers. I'm authorizing it," Bradley said. "Get every welder in Normandy. Strip the beaches. I don't care if it's approved. I care if it works. And it works." He picked up a field telephone and started making calls. Bradley's order went out on June the 24th. 500 tanks. 48 hours. Nobody had ever done a field modification on that scale. Not in this war, not in any war. Tank modifications were supposed to happen in depots, with engineers, with proper facilities. You'd pull a tank off the line, ship it back to a maintenance battalion, work on it for days or weeks, test it, then return it to service. Bradley wanted 500 tanks modified in 2 days, in the field, while the front was still active. The order hit every unit in the American sector simultaneously. Tank battalions, armoured divisions, cavalry squadrons. Every commander got the same message. Pull your tanks off the line in rotation, find a welder, find steel, and get those tusks mounted. The beaches were stripped first. Engineers who'd been clearing obstacles for the past 3 weeks suddenly had a new mission: deliver every Czech hedgehog to inland staging areas. They used bulldozers, half-tracks, anything with a winch. Tons of German steel moving inland. But there wasn't enough. 500 tanks, 4 prongs per tank. That's 2,000 individual pieces of steel that needed to be cut, shaped and welded. The hedgehogs provided maybe half that, so they started scavenging everything else. Railway iron from blown-up rail lines, steel beams from destroyed buildings. Sections of German tank traps. One unit reportedly cut up a destroyed German Panther tank and used pieces of its hull. Every machine shop in Normandy got mobilised. Motor pools, maintenance battalions, engineers. Even some infantrymen who'd worked as welders before the war got pulled from their units and handed torches. They worked in shifts, 24 hours a day. Tanks would roll in, engines still warm from the front. Crews would dismount exhausted and watch welders swarm their vehicle. Acetylene torches lit up the Norman nights like industrial constellations, sparks everywhere. The smell of hot metal mixing with diesel exhaust and French countryside. Curtis Culin moved from site to site, explaining the design, not with blueprints. There were no blueprints. He'd just point at his tank and say, like this, 4 prongs. Angle them forward, weld them deep. Make sure the weight is distributed. Some welders improvised. Longer prongs for tanks that would face particularly thick hedgerows. Shorter prongs for faster, lighter tanks. Some crews wanted 6 prongs instead of 4. Culin didn't stop them. The principle was the same. Bite into the earth, keep the hull level, push through instead of over. Quality control was non-existent. There was no time. A good weld takes time. Proper penetration, proper cooling, proper inspection. These welds were done fast. Some were beautiful, some were garbage. But they held, or they were good enough. 48 hours is not a long time to modify 500 tanks. But on June 26th, when Bradley's deadline hit, the count was 4 times 2 tanks with prongs. Close enough. They called them by rhinos. Officially, they were Plow Culin hedgerow cutters. Unofficially, the crews just called them tusks or Airportbars teeth. The name rhino stuck because that's what they looked like, armoured animals with horns ready to charge. The modification wasn't pretty. Some tanks had prongs that were uneven, some had welds that looked like they'd been done by a drunk apprentice, but every single one of them could punch through a hedgerow without exposing its belly, and that's all that mattered. The operational plan was already in motion. Operation Cobra, the breakout from Normandy. The attack that would determine whether the invasion succeeded or stalled into a grinding siege. The target was the German defensive line south of Saint-Lô, a corridor about 7 miles wide. On the other side was open country, roads, towns, the path to Paris and the interior of France. But between the Allied front and that open country were the hedgerows, hundreds of them. The same killing fields that had stopped every advance for the past 6 weeks. Cobra was scheduled for July 24th. Weather delayed it to July 25th. The plan was simple. Saturation bombing, then armour breakthrough, then exploitation. The Air Force would carpet bomb the German positions with over 2,400 heavy bombers. Then the tanks would roll through the shattered defences. Then motorised infantry would exploit the breach. That was the theory. But everyone knew the bombing wouldn't destroy the hedgerows. It might kill Germans, it might crater roads, but the earthen walls would still be there, and the tanks would still have to get through them. Except now, they had rhinos. July 25th, 1944. 09:38 hours. The bombing started. If you've never seen if you've ever seen a carpet bombing, you can't imagine the scale. Wave after wave of B-70s and B-24s, flying so thick they blocked out the sun, each bomber carrying tons of high explosive. The ground shook. The sound wasn't a series of explosions. It was a continuous roar like standing next to a waterfall made of thunder. It lasted an hour. When it stopped, the German defensive zone looked like the surface of the moon. Craters overlapping craters, trees stripped to stumps, buildings vaporized. But the hedgerows were still there, damaged, torn up, but still standing. Because you can't bomb roots. The tanks rolled forward at 1100 hours. The German defenders who'd survived the bombing were dazed, disoriented, bleeding from the ears. But they were still alive, and they still had their guns. Pak-40s, Pak-43s, some Panthers that had weathered the bombing in defilade positions. They'd done this before. They knew the pattern. The Americans would try to push through. The tanks would climb the hedgerows. The gunners would aim for the bellies. The tanks would burn. A German gunner, his name doesn't appear in any record, so we'll call him what he was, a gunner, sat behind a Pak-43 anti-tank gun in a field south of Marigny. His position was behind a hedgerow, hull down, camouflaged. His ears were ringing from the bombing, but his gun was intact. The auto-loader was jammed, so he was loading manually, but the gun worked. He'd knocked out 4 Shermans in the past 3 weeks, all the same way. Wait for the climb, aim for the belly, fire, repeat. He could hear the American tanks approaching. The sound of diesel engines, the clank of tracks on stone roads. He settled into his position, adjusted his sight picture, and waited. The sound got louder, closer. He could feel the rumble through the ground. His loader crouched next to him, ready with the next shell. They expected the tank to appear at the top of the hedgerow, nose lifting, tracks spinning, that moment of exposure. The hedgerow exploded, not from a shell, from a tank driving through it. The German gunner had half a second to register what was happening. No climb, no exposure, just a Sherman bursting through the wall at full speed, dirt and roots spraying, main gun already tracking, already level. The gunner tried to traverse his Pak 43. Too slow. The Sherman 75 fired first. High explosive round, close range. The blast flipped the German gun onto its side and killed the crew. That happened 500 times in the first hour. German defenders who'd survived 6 weeks of grinding combat, who'd learned to time their shots, who'd mastered the kill zones. Suddenly, their training was obsolete. The Shermans weren't climbing. They were smashing through at speed, guns firing immediately. No pause, no exposure. The German defensive line had been built around a single assumption, that Allied tanks would have to climb. Every gun emplacement, every ambush position, every pre-sighted kill zone was positioned to exploit that moment of vulnerability. The Rhinos eliminated that moment. By 1400 hours, 3 hours into the attack, the American armoured columns had pushed 5 miles past the German front line. 5 miles in 3 hours. In hedgerow country, that was unheard of. The previous record was 5 miles in 3 weeks. German units started falling back, not in organised retreat, in panic. Their radios were full of reports that didn't make sense. By size, the tanks are coming through the walls. They're not climbing. They're not climbing. Commanders ordering units to reposition, but there was nowhere to reposition to. The Rhinos were already behind them. By evening, the German defensive line south of St. Lo had collapsed. Not cracked, collapsed. The units that had held for 6 weeks broke and ran in 6 hours. The breakout had begun. Over the next 3 days, American armour pushed 20 miles into the German rear. They bypassed strongpoints, cut supply lines, encircled entire battalions. The hedgerows that had protected the Germans became a liability. The Germans couldn't see the Americans coming until the Rhinos were already through the walls. The entire campaign shifted. The static, grinding siege warfare of June and early July turned into mobile warfare. By August, Allied forces were racing across France. The Germans were in full retreat. And it started with 500 tanks and 48 hours of welding. General Bradley later wrote in his memoirs that the Rhino modification saved the invasion. That's not hyperbole. Without it, the breakout from Normandy would have taken weeks or months. The Germans would have had time to fortify the interior, bring up reserves, maybe even stabilise the front. But the Rhinos broke them, not through firepower or numbers, but through engineering, through improvisation, through a sergeant who decided to weld teeth onto his tank because he was tired of watching his friends die. Curtis Culin got a medal. But that's not where the story ends. Curtis Culin received the Legion of Merit on August 4, 1944. The citation read, "Erstürmen for exceptionally meritorious conduct in the performance of outstanding service in solving a critical tactical problem through individual initiative and ingenuity." Translation: for ignoring the chain of command and welding without permission. The ceremony was brief. An officer pinned the medal on Culin's uniform in a field somewhere in France. There were no reporters, No photographs that made it into the papers back home. Just a sergeant getting a piece of ribbon for saving the invasion. Culin didn't give speeches. He didn't write about it. Years later, when historians tracked him down, he'd say things like, "Well, it seemed like a good idea," or "Someone had to try something." The kind of understatement that drives historians crazy, but is typical of the men who actually do the work. The numbers tell the story better than Culin ever did. Estimated Sherman losses prevented by the Rhino modification, 300 to 400 tanks. That's a conservative estimate based on casualty rates before and after Cobra. Some analysts put it higher. Crew lives saved, 1,500 to 2,000 men, 5 crew members per tank. Do the math. Time saved in the breakout from Normandy, WWII, 4 to 6 weeks. Again, conservative. Some planners thought it would take until October. It took until the end of July. Cost per tank modification, $0. The steel was scavenged. The labour was done by men who were already being paid to be there. The only cost was time, 48 hours of welding. Total material cost for the entire program, nothing. They used enemy steel to defeat the enemy. But there's another number that matters. Curtis Culin lost his right leg in combat 4 months later during the push into Germany. A mine. He survived the blast, survived the field hospital, survived the infection. They shipped him back to the States in early 1945. He returned to Cranford, New Jersey. Worked in a machine shop again, got married, had kids, lived a quiet life, no parades, no talk about title entry, no national recognition. The Army, meanwhile, took credit for the Rhino modification. By September 1944, official field manuals included instructions for mounting hedgerow cutters on Sherman tanks. The language was bureaucratic. Plow, tank crews are authorised to fabricate and install forward-mounted cutting devices using available materials. Authorised, as if permission had been granted before the fact. The manual didn't mention Curtis Culin by name. It didn't mention the 48-hour welding sprint. It didn't mention that the modification had been designed, tested and deployed before anyone in the engineering corps signed off on it. It just said, authorised. By late 1944, every Sherman tank in the European theatre had some version of the Rhino. Richot prongs, they became standard equipment. New tanks rolling off assembly lines in Detroit were being fitted with them before they were shipped overseas. The modification that had started as unauthorised field improvisation became official doctrine. But the authorisation came after the battle, after Cobra, after the breakout, after Curtis Culin had already proven it worked. That's the pattern. That's always the pattern. The individual closest to the problem solves it with whatever tools are available. The system observes the solution, studies it, tests it, and eventually adopts it, taking credit for authorising what was already working. It's not malicious, it's just how bureaucracies function. They move slowly because they have to account for everything: logistics, safety, doctrine, liability. An individual can take risks that an institution can't. An individual can weld scrap metal onto a tank at midnight and test it at dawn. An institution needs committees. But wars aren't won by committees. They're won by sergeants with welding torches. The Rhino modification saved the Normandy invasion. That's not an exaggeration. Without it, the breakout would have stalled. The Hedgerows would have continued to be killing grounds. The Germans would have had time to stabilise the front, bring up reserves, fortify the interior. The entire trajectory of the war in Europe might have been different, and it was solved by a man who didn't wait for permission. Curtis Culin died in 1963 at age 54. Heart attack. He was buried in Fairview Cemetery in Westfield, New Jersey. His obituary in the local paper mentioned that he was a veteran, that he'd been wounded in the war, that he worked as a machinist. It didn't mention the Rhino. It didn't mention Normandy. It didn't mention that he'd changed the course of history with 4 pieces of scrap steel. Because that's not how these stories usually end. The man who solves the problem rarely gets the recognition. The system that adopts the solution gets the credit, and the individual goes back to his life missing a leg, carrying a medal in a drawer somewhere, knowing that he did what needed to be done. There's a photograph, one of the few that exists, of Curtis Culin standing next to his Sherman in June 1944, just after Bradley's order went out. He's covered in grease. His uniform is filthy. There are welding burns on his sleeves. He's not smiling. He's just standing there looking at the camera, next to a tank that looks like it's growing steel teeth. Behind him, you can see other soldiers welding, cutting, hauling steel. The 48-hour factory in full operation. And in the background, barely visible, you can see the hedgerows that had killed so many men. The photograph was taken by a Signal Corps photographer who was documenting the modification process. It was filed away in an archive somewhere. It didn't make it into the papers. It didn't become famous. But it tells you everything you need to know about how problems actually get solved. Not with PowerPoint presentations, not with feasibility studies, not with committee approvals, with dirty hands and stolen steel and a willingness to weld first and ask for permission later. The Rhino modification became doctrine. It's in the manuals now. It's taught at armour schools. Future tank designers study it as an example of field expedient engineering. But when they teach it, they rarely mention Curtis Culin's name. They talk about Bocage field modifications, Plows, and Bocage's tactical innovation, us, and Bocage's adaptive problem-solving. They don't talk about a sergeant who was tired of watching his friends burn. They don't talk about the fact that he solved the problem in 3 days while High Command was still forming committees. They don't talk about the fact that he used enemy steel to defeat the enemy. And they don't ask the question that matters most: how many other problems? In that war, in this war, in every organisation, in every system, could have been solved by the people closest to them if they'd just been allowed to weld without waiting for permission.